Today, let's start diving into basic data types of the Go programming language. And the first set of types we're going to check are integers. Integers represent whole numbers. There are several signed integer types that represent negative and positive numbers of different sizes. For example, we have int 8, int 16, int 32, and int 64, and corresponding unsigned types, which are uint 8, 16, 32, and 64. On top of these types, Go provides int and uint types, which are more commonly used. The interesting part is that the Go compiler picks the most efficient size for those types, depending on the platform of a program is compiling for. In other words, on some platforms int can represent int 32, and on the others it will be int 64. But all that is happening under the hood and we shouldn't worry about it most of the time. The int8 type has a synonym called byte. And there is also a type room, which is synonym for int32 and represents Unicode code point. Now let's check what we can do with integers. First of all, we can apply different arithmetic operations with those types, and we can add them together, subtract, and so on. Here's the complete list of these operators. Now let's run a couple of examples. In this example, we are going to define two integer variables. Then calculate their sum and their difference. Then run the program and check the result. Even though all the types mentioned above are integers, we need to be careful when working with them, because they are still different types. For example, if we try to define two variables of different integer types and then try to calculate their sum, the program will not compile. To fix that issue, we can cast both values to the same type. This time the program compiles and prints the result on the screen. We can also compare integer values to check if they are equal, not equal, less than, and so on. Another caution we should keep in mind while working with integers is that every type has their, let's say, min and max values. If you try to jump over those values, that can lead to overflow. Let me show that on the example. We define a uint variable with a value of 1 and then subtract the 2 from it. Then we define uint variable with a value of 255 and then add 2 to that variable. When we run the program, that produces the result what we might not expect. As you can see, we have two variables that can hold a value between 0 and 255, and we cannot jump outside of these boundaries. That was a quick look at integers in the Go programming language.